Hi students, welcome to my lectures on thermodynamics. In the today's lecture, we are going to discuss about state functions and path functions. Okay, the state functions are those which dependent only on initial state and final state. Path functions are those which depend upon how the system has taken state 1 to state 2, whether they have taken this route or this route or this route. Okay, depending upon the path it has taken, the value of the path function will be defined, whereas the state function, irrespective of the path, okay, it depends only on initial state and final state. Let us see on the board. Okay, if you see on the board, I have plotted a graph on pressure and volume, PV. These are the thermodynamic properties: pressures, volume, temperatures, internal energy, enthalpy, entropies. This everything comes under the state functions. Okay, whereas heat and work, there are path functions. Let us state, okay, there is a system which is at the state 1, it is denoted by 1, and the end state, which is the state 2, is denoted by 2. Okay, if I calculate, you can take the system from state 1 to state 2 in any one of the three paths. That is, you can take through path A, you can take through path B, you can take through path C. Any, okay, irrespective of the path, any path it may be. The final pressure, initial pressure and final pressures are the same. Initial volume and final volume are the same, because here it is P1, it is V1, here it is P2 and V2. So whichever may be the path, the P2 minus P1 or V2 minus V1 are the same. So this is the typical state functions. Okay, let us take for example, I have drawn some areas. As I told you that heat and work are path functions. Example, you can bring that state 1 system from state 1 to state 2 in any one of the paths. Path, for example, in other words, it's called the process. That means you can bring the system from state 1 to state 2, maybe at constant pressure path, constant volume path, constant temperature path, adiabatic path, polytropic path. There are different paths or processes that are available to bring this system from state 1 to state 2. Okay, let us designate some areas. As I told you that these heat and work are path functions. Path functions means it depends on the area under the curve. It's not depending upon the end, initial state and final state. Okay, it depending upon the area under these curves or processes. Let us, okay, area under the C curve is denoted by A1. Between A curve and C curve it is A2, the area between these two curves, and area between A and B, that means A process and B process, is A3. As I told you, right, let us see let us calculate the work. Okay, it will be more easy because work is a path function. So because it's a piston and cylinder assembly, because generally people work with the pistons, right? Okay, then work can be calculated using the formula minus integral V1 to V2 P into dV. That means wherever you see the integral symbol, that means we are talking something about the area under the PV curve. Okay, and let us using this, let us see area under the curves, because I already designated what is the area under the curves. And if you come to the state function, state 1 to state 2, what is the difference between the pressure? P2 minus P1. And what is the difference between the volume? V2 minus V1. That means what is the delta PA? That means if the system follows the path A, what is the difference between the pressure? P2 and P1. If your system follows the path B, again the pressure difference is this is P2 and P1. If the system follows the path C, again the pressure difference is P2 and P1. That means irrespective of the path, the pressure difference is P2 and minus P1. This is the typical example of state function. Similarly, volume. The initial volume is V1, final volume is V2. Whether it has gone through path A or path B or path C, any path, the value of the property, the difference is V2 minus V1. Let us see the state functions, path function. That is why delta PA, that is pressure difference in path A, is P2 minus P1, path B is also P2 minus P1, path C P2 minus P1. Similarly for the volume. If you see, let us calculate the work requirements in different paths. Work requirement in A, minus integral P1 to P2 PA into dV. Okay, because the system has taken the path A, then what is the work requirement? Work requirement means area under the curve A. How many areas are under the curve? One is this area, which is A2, another one is this area, which is A1. So area under this curve A is nothing but A1 plus A2. That is why work requirement when the system has taken from path 1, state 1 to state 2 through path A is nothing but A1 plus A2. Similarly, let us take, if the system has taken from path B from the state 1 to state 2, what is going to happen? The area now it is changing. How many areas are there? Because the work is nothing but area under the curve PdV, which is the displacement work. Okay, now you have to add together all the curves. Area under the curve means A3, which is between these two areas, between these two and between these two. Okay, A3 plus A2 plus A1. Now if you it's a more work requirement is there. Okay, A1 plus A2 plus A3. Work requirements through path C. That means if the system has taken from path 1 to path 2 through C process or C path, state 1 to state 2, using the path C, the work requirement is only A1 because area under the curve only one area is available. Now you can see, that means when you talk about the state functions, the value is the same. When you talk about the path functions, the value of the path depending upon the route it has taken. For A route, it is A1 plus A2. Through B route, A1 plus A2 plus A3. Through C route, which is only A1. That means area work through path B is greater than work through path A, which is greater than work through path C. That is, path function have different values for respective path, but the state functions irrespective of the path, now you have the same value. This is what the typical difference between state functions and path function. I hope now you understand what exactly the state and path functions. Now let us move forward for some other lecture. Thank you very much.